Well, I mean, there's a whole wide range of devices that we can use, and then from the devices, then what are the applications come next? What are we actually going to be doing? If we've got phones with NFC, with the near-field communication, we can have a phone that can read a smart card. We can have handheld computers. I've got a couple here. Here's a cheap one. I say that in the general sense, as in it's an ARM-based device where its role in life is to run the one program that you throw onto it. You download the program and it says, okay, I'll do that, and that's all it does. It's ARM, you program it in C or C++, a special development kit for it, fair amount of money to buy the development kit, but these things are cheap. And if you want, well, somebody mentioned charities, fair enough. These things, ideal if you've got a cashless society and you've got Wellington railway station, people pouring off the trains, and they say, no, sorry, don't have any cash on me. But if you can tap their snapper cards with this, then it's an application that you can do it. So, cheap devices. These also have got rooms for basic SIM slots, or SAM slots, how we call them, in there, so you can have a couple of these devices living inside here. So if you've got an application that requires some extra behaviour in negotiating with the card, you can put those secure devices in here and have a common application on the device. Then you go up to bigger, heavier things. That's I can do absolutely anything. That's got a smart card reader, which is, for this one, is actually on the back, but it's got everything. It's got GPS, it's got phone, it's got a camera, it's got an infrared reader. So that's do absolutely everything, and I'm sure you could actually smack somebody on the head and lay them out with that thing. But that is a range of, where you can look at it, a range of devices that you can use, depending on the application, the cost model, and what have you, what you want to do. Then, of course, you've got laptops, ranging from the small laptops to the bigger laptops. Some of them now come with the smart card readers built into them. I've seen ones with the contact ones, and in time we're going to see them with the contactless. And then also you can stick a contactless reader onto a smart card. We've seen people with their Vodems and various attachments all hanging off the USB. Well, this is yet another thing to hang off your USB. In the general purpose computers, if you've got a standalone setup, imagine you've got a clerk or a secretary or something, they can then have a device like that which sits happily on the desk. So they've still got the capability of reading a smart card. And in this case, this also works with the contact card as well. So contactless on the top and the contact. Then we've got turnkey systems. So I mentioned car parks. So here, that's the kind of thing that you'd have a car park. You can deal with your contact card. That would, when you come to the barrier and you need to pay, you then have to lean out and shove that in their boxes, and then you try and grab it down again. So contact, well, we're trying to move away from contact. So what you want to do is use basically the equivalent thing, but for a contactless one. Where here is an example where the aerial is around here, so you'd have a facial plate, and then you put your card up to here. So there you've got a robust, industry standard, certified device that you can stick in a vending machine, or whatever you want to do, library or whatever. So embedded systems. See the buses, they've got what we call validators, the tag on, tag off. They've all got the contactless reader within those devices. They also have a couple of these devices within each of the validators. So they have contact smart card readers inside them, and they have contactless for the snap card. And then security systems. They've started off with RFID, where you have a simple token which just gives a unique number. Okay, this is Joe Bloggs coming to work. With the smart cards now, you can put more and more information onto the smart card. And also you can have the same smart card doing different security systems. So if I want entry to totally different ways, just like I can have different applications on the card, I can have different, I can be given different access rights on the card, and not by, I don't have to have a shared security system validating the card. So now we need to communicate with the reader. How are we going to do that? So, PCSC compliant, that stands for Personal Computer Smart Card. Where that matters is if I've got something and I plug it into the machine and it's Windows and it just works, then it's likely to be PCSC. It means the drivers, PCSC is a standard. If you have built your device to conform with that, then Windows will quite happily download a standard driver. Okay, we're off and running. Then we can use a Windows API to talk to it. Also on other platforms, they recognise PCSC devices. You can also have serial devices where it isn't a, depending on the device, they said, well, it's better if we do it our own way. It's going to be for an embedded system, so we're not worried about standard drivers. What we're worried about is cost. And so you can get devices which run over serial, USB, even if they're USB doesn't automatically turn them PC compliant. And then you've got the all-in-one device. I'm going to wave this little thing about. Has anybody seen these things? They're an uncommon snapper card, but this thing, it's got a USB contacts on the end of it, and so when you plug it into your PC, it's a PCSC compliant reader. Then the next thing is, it's a snapper card. That reader interface then appears to the operating system like it's a reader with a permanently attached snapper card. That's great. So no drivers, plug it in, you can read it. If you bought one of these, you can just stick it into either a Linux box or a Windows box and you can play with these from day zero. But also, because they're snapper cards, they're contactless as well. So you've got the USB reader to make it PC compliant, and it will work on a contactless reader because they work by radio. And then here's that's a Korean sample. It's basically exactly the same device, but it's a Korean. It looks to me like a dummy. So you can have the same device but looking quite different. In terms of USB, the standard snapper feeder, that's one type, that's another type. They're exactly the same. They've got the same Philips chip inside them. They plug in USB, but they are not PCSC compliant. However, there is code out on the net which will let you drive these things. Which is right. So, we know we've got our cards, we know what the cards can do. We've got our readers, we know where we want to deploy this thing, now we've got to start writing the code. How are we going to talk to, your job really is how am I going to talk to the reader, then how am I going to build the application behind that. So I'm just going to say, well, how are you going to talk to the reader? If you're on Windows, your first stop is if it's PCSC compliant, or if the device manufacturer has provided additional drivers, you can get away with WinScard. There's a standard API set just like WinSock for sockets. WinScard is a standard API for talking to smart cards. It doesn't matter whether it's contactless or contact, use the same APIs, and the goal is to send the APDUs. And that's what WinScard lets you do. Unix, there's whatever Windows can do, we can do as well. So we have PCSC Lite, and this provides the WinScard API. So you've got your PCSC devices that you can use in Windows, you can use in a Linux, a Mac OS X or Solaris or whatever, and use exactly the same API set to talk to them, which I think is absolutely great. Then libNFC. NFC is the near field communication. They provide a library which will talk to these things. Because it's open source, that thing is nicely layered. They use libUSB to talk to it, so they're talking over USB. Then libNFC uses the NXP is a spin-off from Philips. Tama, I'll try to find out what the acronym stands for, but I failed miserably there. Tama is a standard byte sequence for talking to Philips chipsets, NFC chipsets. So libNFC has gone out of the way to providing a library that you can use to talk to these things. Then the Java world, we've got Java on the smart card, and we've got Java on the server, on the computers that are going to read those smart cards.